Right, Putala. Today we are going to discuss our 18th paper. In this paper, we'll discuss question related to projectile motion. Right, Pute? Let's see the first question. The height of a step in a staircase is simple h, and the width is x. Height h, width is given as x. Right, Pute? An object is projected horizontally from the edge of a certain step. Right. Then, after the object is projected with that horizontal velocity, it collides with the nth step below that step. Projected horizontally from the edge of a certain step, and then it collides with a nth step below that step. ළමයි මෙයා මෙහෙම project කරාම පස්සේ n step එකකටලු වැටලා තියෙන්නේ. Right? Then you can observe that if there are 3 steps, what should be the vertical height? Vertical height should be equal to 3h. Horizontal displacement, there is an important sentence. What is the maximum horizontal velocity? When this object is moving with maximum horizontal velocity, this object will obtain maximum horizontal range. That means this object will collide with the nth step at the far end. Maximum horizontal range. Therefore, if for the nth step, horizontal range should be equal to 3n into x. Vertical displacement should be equal to n into h. Then you can apply equations, right, Pute? For the vertical motion to the downward direction, displacement is n into h, initial velocity 0, time interval t, half into gravitational acceleration g, time interval t squared. Then nh is equal to gt squared over 2, then 2nh over g square root is equal to t. This is the time taken by the particle to hits the end step. Then you can obtain the horizontal displacement by applying s equals ut to the horizontal direction. Horizontal displacement is n times x. U initial velocity, you need to find u. Then 2 time interval is 2 nh over g square root. Then the answer is u is equal to nx g to nh square root. You can bring this term n ඇතුළට ගන්න පුළුවන් නේ. Then x times ng over 2h. Which one is the answer? X time ng over 2h. First one is the answer. Right, Pute? Let's see the next question. Right, Pute, let's see the answer for the second question. It was calculated that a shell, when fired from a gun with a certain velocity at an angle of elevation 55 over 36 radian, should strike a given target in the same horizontal plane. In practice, it was found that a hill just prevented the trajectory. Right. අපි diagram එක දාගෙන බලමු. Initial velocity of the bullet is u. Here you should remember, you cannot change the magnitude of this velocity. It is a constant, right? Gun එකෙන් bullet එකට දෙන initial velocity එකේ magnitude එක, it is a constant. You can change the direction of the velocity by changing the position of the gun, right? Then this angle is given as theta is equal 5 phi over 36 radian. Then they have given that this hill prevents the motion at this horizontal displacement x. Right, Pute? Then what is the question? At what angle of elevation should the gun be fired, hit the target? Pute, here you need to obtain same horizontal range, but you need to obtain greater vertical displacement at this horizontal displacement. That means you need to increase the angle of projection. Pute, first try to identify this angle in decrease. 25 radian කියන්නේ 360 වලට නම් decrease නම් 5 over 36 කියන්නේ කාටද 5 ට 5 cancel වෙනවා over 36 නේ then මෙතන 1යි මෙතන 10යි මෙතන 1යි මෙතන 5යි 25 degrees. That means angle of projection is 25 degrees. Pute, to obtain same horizontal range, what should be the other angle? They are complementary angles. අපි කතා කරලා තියෙනවා. Then 90 minus 25 is the angle. 65 degree. When you project this object at an angle 65 degree, you will obtain same horizontal range for this initial speed. And here you have increased the angle of projection from 25 degree to 65 degree. That means this object will obtain greater vertical displacement at the same horizontal displacement. Therefore, the answer is 65 degree, but you need to convert this angle into radians. 365 degrees කියන්නේ 25 radian වලට නම් 65 degrees කියන්නේ කාටද? Then you can divide by 5 times 13, 5 times 72, I cancel, 36. Then 13 phi over 36. This one is the angle. Which one is the answer? 13 phi over 36, fourth one. Fourth one is the answer. Right, Pute? Here you need to note two theory points to obtain same horizontal displacement for given initial speed. There are two angles of projection, 25 degree and the other complementary angle 65 degree. හැබැයි පුතේ maximum horizontal range එකට තියෙන්නේ 1යි 45 degree. Then to prevent this collision between this hill and the bullet, you need to increase this vertical displacement at the same horizontal displacement. Therefore, you need to increase the angle from 25 degrees to 65 degrees. Got it? Let's see the answer for the next question. Right, Pudala, let's see the answer for the third question. An object is projected at a certain velocity so that it has maximum horizontal range. Today, to obtain maximum horizontal range, R max, this object should be projected at an angle 45 degree with the horizontal. This one is the first theory point you need to know to find the answer for this question. Let's see the question. If the maximum horizontal range achieved by the particle is 160 meters, what is the maximum vertical height the object will obtain? Here you need to find maximum vertical height at the maximum horizontal range. Again, R maximum වෙනකොට projected angle එක 45 degree වෙනකොට you need to find this maximum height. Got it? Pute, you should know the ratio between R max and H. It is equal to 4. Again, when theta is equal to 45 degree at the maximum horizontal range, ratio between the maximum horizontal range and maximum height of that projectile is equal to 4. අපිට මේක ගන්න පුළුවන් ළමයි මේ range you can obtain u squared sin 2 theta over g no. at R max, theta is equal to 45 degree balance. R max is equal to u squared sine 2 into 45 over g. Then u squared sine 90 over g. Sine 90 is equal to 1. Then R max is equal to u squared over g. Then you can obtain maximum vertical height by applying equation for this initial vertical velocity component. If the initial velocity is u, vertical component is u sine 45, no, u over root. V squared is equal to u squared plus 2as, v squared 0 at the maximum height, u sine 45 squared minus 2gh. මෙයාව මේ පැත්තට ගන්න පුළුවන් 2gh u squared sine squared 45 u squared over sine squared sine 45 උතේ 1 over root 2 එක squared එක වෙන්නේ 2 1 over 2 then h is equal u squared over 4g. Then you can identify the ratio between R max and h. Right, Budhe? This theory point you need to know. To obtain maximum horizontal range, object should be projected at an angle 45 degree. When an object projected at an angle 45 degree with the horizontal or vertical, ratio between the horizontal range and maximum height is equal to 4. Right? That means maximum height is equal to 160 over 4, 40 meters. Third one is the answer. Right, Pudala, let's see the answer for the question number 4. Pute, this question is the most important question in this tube. Right, Pute? Right, let's see the question. An object that moves on the ground can jump maximum horizontal distance of 0.05 meter at a time. ඔයාලා දැකලා තියෙන අර පොළොවේ මෙහෙම පැන පැන යන ටික්කොනේ. බස් ටික්කොනේ මේක හොඳද? වැලි වල පැන පැන යන ඉන්නවා. Right? A small insect that moves on the ground can jump a maximum horizontal distance of 0.05 meter at a time. If the insect continuously jump like this, velocity of it is right on the ප්‍රශ්නය. පුතේ මේ insect මේම පයින්නවා. To find the answer, you need to consider motion of the insect during a one jump. You can isolate one jump. In this question, they have given during a jump, it obtain maximum horizontal range. This insect obtain maximum horizontal range. What is the theory point? The projected angle should be equal to 45 degree. බලන්න මෝ හරියට මැනලා පයින්නවා ළමයි හරිද? To obtain maximum horizontal range 0.05 meter, this insect should jump 45 degree with the horizontal. Got it? Then you can identify initial velocity of the insect. Why? Now you know projected angle is 45 degree, range is 0.05 meter. This one is the equation. Horizontal range equal u squared sine 2 theta over g. Right? You should remember these equations, right? For the MCQs, you should remember this equation, right? මේව derive කර ඉන්න ගියොත් අනිත් අය through MCQ ටික කරනවා. ඔයා derive කර ඉඳීවි. දැන් කෙනෙක් කියයි නෑ මම ගිරව දාන්නේ නෑ මම දෙන්දි derive කරනවා කියලා. ඉතින් කමක් නෑ එහෙම වුණොත් MCQ 35ක් විතර කියවන්න බලාගෙන විභාගයට ඵලයන්. 50 කියන්න වෙන්නේ නෑ. right? අයි මේවා බං physics නෙමෙයි දැන් මේව ගිරව. මේව පාඩම් කරලා ඉවර වෙන්න ඕන. physics කියන්නේ මෙතනින් එහාට හිතන්න තියෙන දේ මේකට apply කරන්න තියෙන එක බලන්න. ඔයාලට කියලා තියෙනවා මේ insect කෙනෙක් පැන යනවා කියලා. Then you need to assume that this motion as a projectile motion, set of projectiles. Easy නේ? තේරුණාද? එතකොට අපි ඒකෙන් එක projectile එකක් අරගෙන you need to find the velocity of the insect, initial velocity of the insect according to this projected angle 45 degrees. Right? Right? Range is 0.05 Uday, U squared. To obtain maximum horizontal displacement, this angle should be equal to 45 degree over G is 10. Then 0.5 is equal to U squared sine 45 into 290, sine 90 is 1. Then you can obtain velocity of the projectile, velocity of the insect is 0.5 square root. පුතේ දැන් මෙතන no need to find square root of 0.5. 0.7 into 0.7 is 0.49. That means square root 0.5 should be equal to 0.7 something මොනවා හරි. Right? U should be equal to 0.7. Right. When you observe the velocity of this insect, you will observe this horizontal velocity component as the velocity of the insect. U cos 45. U is 0.7 cos 45. Why? You will not observe this vertical velocity component. Why? Here you will measure the velocity of insect parallel to the substrate. No? ඒ කියන්නේ අපි මෙයාගේ මේ substrate එකට parallel component එක තමයි ළමයි velocity එක විදියට දකින්නේ. Therefore, you need to consider velocity of the insect parallel to the substrate. That means U cos 45, 0.7 into cos 45 is equal to 1 over root 2, 0.7 divided by 1.41. මෙතන 1, 2, 0.5. Answer is the first one. Right, Pude? Right. Right, Pudala. Let's see the answer for the question number 5. An object is projected at an angle 60 degree with the horizontal and with an initial velocity 60 meters per second. Initial velocity U is equal to 60 meters per second. Angle is 60 degree. The time it takes for the motion of this object to become perpendicular to its initial velocity, right? Udala, motion of the particle at t equal t, motion of the particle at t equal t. Then the velocity is in this direction, v. This one is the direction of the initial velocity. Now the velocity is acting towards this direction. According to the question, at t equal t, velocity become perpendicular to the initial direction of velocity. Try it, Pude. This question is a slightly different question, right, Pude? In the normal projectiles, we consider the motion of the projectile, vertical motion and horizontal motion. But this question, you need to consider the motion of the projectile parallel to the initial velocity. Right, Pude? Let me explain. Right, Pude? Right. First of all, you need to identify meaning of this sentence. The time it takes for the motion of this object to become perpendicular to its initial velocity. පුතේ මේක තේරුම දැනගන්න ඕන. When the velocity of the projectile becomes perpendicular to initial velocity mean this velocity cannot give a component towards the direction of the initial velocity. Why? Now this angle is 90, no? V cos 90 is 0. That means at this instant, velocity of the projectile towards the initial direction becomes 0. Right, පුතේ? මේ sentence එකේ තේරුම දැනගන්න. මෙයාගේ velocity එක initial velocity එකේ direction එකට perpendicular වුණා කියන එකේ තේරුම මෙයාට පුතේ මේ පැත්තට component දෙන්න බෑ. If you consider a component, it should be equal v cos theta. Now theta is 90, cos 90 is 0. It cannot give velocity component towards the direction of the initial velocity. That means at this instant, if you consider the velocity of the projectile towards the direction of initial velocity, it reduces, continuously reduces, and at t equal t, it becomes 0. Then you need to identify acceleration of this projectile towards the direction of initial velocity. Let me explain. This gravitational acceleration is acting vertically downward. To identify this acceleration, you need to consider this component of this gravitational acceleration parallel to the direction of initial velocity. This angle should be 60 degree. That means this one is 90, then 30. This one is the component. G is the result, and then the component is G cos 30. Now you can observe that this acceleration component acts opposite to the direction of initial velocity. That's why this initial velocity reduces. Make aduela at this time interval it becomes 0. Right? Now you know the initial velocity, acceleration parallel to the initial direction of initial velocity, and final velocity 0. You can apply this equation v equals u plus at towards the direction of the initial velocity. Utala, what are the conditions that should be satisfied by the object to apply equations? Equations in linear motion. Object should be moving in a straight line. The second one, acceleration should be a constant. Here you have considered the motion of the projectile towards the direction of the initial velocity. ඇත්ත මෙහිදී particle එක curve path එකක යන්නේ, but here you consider the motion towards the direction of initial velocity. No, it is a straight line. Second point, when you consider this component, gravitational acceleration component, it is g cos theta, it is a constant. It acts opposite to the direction of velocity. That's why particle decelerate. At time t equal to, it becomes 0. Now you can apply equation. Initial velocity is 60. This one is not g. G cos 30 into t, final velocity is equal to 0. 0, 60 minus 10 cos theta root 3 over 2 time t. You can bring the term to the opposite side. 10 root 3 over 2 into t is equal to 60. මෙයා පහයි t equals 60 over 5 root 3. මෙතන 12යි. Rationalize කරමු නේද ළමයි? 12 over 13. You can multiply both numerator and denominator root 3 වලින්. Then 3යි. 3 වරක් 1යි 3 වරක් 4යි. 4 root 3 is the answer. At t equal 4 root 3 seconds, velocity makes an angle 90 degree with the direction of initial velocity. Right, පුතේ මේක හොඳ question එකක්. මේක practice කරන්න. දැන් ළමයි මම ඔයාලට කියන්නම් වැදගත්ම දේ මේකෙදි. හරිද? දැන් ඔයාලට තේරෙන්නේ මෙතන අපි question set එකක්ම කතා කරා. එතකොට පුතේ ඔයාලා කරන නරකම දේ තමයි නරක නෑ ඒක කරන්න ඕන. ඔයාලා මේ questions ටික මම කියන recording එක බලලා මේ questions ටික තේරුම් අරගෙන කොලයක ලියලා පැත්තකින් තියනවා. ඒක මදි පුතේ මතක තියාගන්න. A level කරන ළමයි 100ක් ගත්තොත් 90ක්ම ළමයි ওই වැඩේ කරනවා. හැබැයි ඔයාලා කරන්න ඕන ඒක නෙමෙයි. ඔයාලා කරන්න ඕන පුතේ දැන් මේ MCQ එක first time ඔයාලා තනියෙන් කරා නම් පට්ට. එහෙම කරන්න බැරි වුණා නම් recording එක බලලා තේරුම් ගන්නවා. ඊළඟට පුතේ මේක කොලයක ලියන්නේ නැතුව තනියෙන් දැන් ඔයාලට මේක විභාගෙදි විනාඩි 2යි විනාඩි 2යි තප්පර ගානකදී answers දෙන්න තියෙන්නේ. එතකොට ඔයාලට මේක ඒ විදියට answers දෙන්න පුළුවන් විදියට මේක හිතෙන් හදා ගන්න ඕනේ. මේකට answer එක ගන්න විදිය උඹලා හිතෙන් practice කරන්න ඕනේ. ඔයාලා ඒක කරන්නේ නැතුව මේක ඔයාලා ගොඩක් අය කරන්නේ 90%ක්ම කරන්නේ මේක තේරුම් අරගෙන ලියලා කොලයක වහලා පැත්තක තියනවා. ඒක වැඩක් වෙන්නේ ආයි අමතක වෙනවා. අර මේක මේ thinking pattern එක අමතක නොවන විදියට ඔයාලා මතක හදා ගන්න ඕනේ. තේරුණා නේද? ඒක කරන්නේ ළමයි ටික දෙනා. ඉතින් මම ඔයාලට කියන්නේ ඔයත් එහෙම කෙනෙක් වෙන්න. එතකොට මේ question එක මේ pattern එක ආපහු exam එකකදී ඇහුවොත් ඔයා ගාව store වෙලා තියෙනවා ඒ memory එක. ඔයා එතකොට ටක් ගාලා thinking pattern එක apply කරා ගාන හැදුවා. තේරුණා නේද? දැන් ආයි තැනකට ආවොත් හිතලා හදන්න මේක කරලා වැඩක් නැහැ නේ. දැන් ගාන හදලා ඉවරයි නේ බං. තේරුණාද? දැන් මෙතනින් පස්සේ මේ thinking pattern එක ඔයා store කරගෙන තියන්න ඕනේ. ඇහුවොත් ඇටියල එන්න දෙනවා කියලා. තේරුණා නේද? ඒක නිසා මතක තියාගන්න තනියෙන් ගාන හදන්න try කරන්න. බැරි වුණොත් recording එක බලලා ගාන fix කරගන්න, solid කරගන්න. ඊළඟට තනියෙන් හිතින් හොඳට practice කරන්න මේක ඉස්සරහට පිටිපස්සට කොහොමද මේ answers ගන්න කියලා. කොලේක ලියන්නේ නැතුව තනියෙන් ගන්න තැනට හිත හදාගන්න. හිතෙන් මේ thinking patterns develop කරගන්න. අන්නේ memory එක store කරලා තියාගන්න. ඒක තමයි වැදගත් වෙන්නේ. තේරුණා නේද? ඔයක තුන්වෙනි step එක. තනියෙන් ගාන හදන්න try කරන්න ඉතින් recording එක බලලා ලියා ගන්නවත් ඇති. හැබැයි අර third එක ගොඩක් අය කරන්නේ නැහැ. හැබැයි මතක තියාගන්න මේක තමයි කරන්න ඕනම දේ. තේරුණාද පුතේ? අපි බලමු ඊළඟ MCQ එක. Right, Pute, let's see the answer for the question number 6. Consider the motion of an object projected vertically upwards with an initial velocity u until it passes its starting point again. If this object experiences air resistance during the motion. Right, Pute? Let me explain the motion of this object if there is no frictional force acting on it. Right, Pute? This is the object, projected initial velocity u. Then, due to gravitational pull, velocity reduces. At the maximum height, velocity becomes 0. Then it falls down. When it hits the ground, velocity, magnitude of the velocity is again u. This theory point we discuss in motion under gravity lesson, right? Throughout the motion, this gravitational acceleration acts downward direction. Then I will draw a velocity time graph for this motion by considering physical quantities which are acting upward direction as positive physical quantities. ඒ කියන්නේ මම upward direction එක ළමයි positive කියලා හිතලා velocity time graph එකක් අඳිනවා. Let me explain. V versus T. Object is projected initial velocity u. It reduces first. At the maximum height, it becomes 0. Then it again increases, but increase towards the downward direction. Therefore, it increases negatively. You can observe that throughout the motion, this gravitational acceleration acts downward direction. Therefore, acceleration of this motion is a negative acceleration, constant negative acceleration. You can observe that this angle is an obtuse angle. Therefore, tan alpha is a negative value. Right. This area is equal to the maximum height. At the maximum height, velocity becomes 0. Then again, velocity increases. These two velocities are equal. These are the point you need to know if there is no frictional force acting on the object. Right, Pute? Let's see the question. දැන් අපි බලමු ළමයි frictional force එක act කරනකොට මොකක්ද වෙන්නේ කියලා. Let me explain. When the frictional force is acting on the object, it projected with the same velocity at t equals 0. Then you can consider the motion. Put a frictional force always opposes the motion. It acts opposite to the direction of the motion. Now you can observe that in previous case, this gravitational force produced the acceleration. This acceleration towards the gravity. But in this case, there are two forces act when the during the upward motion, there are two forces acts on the object. Gravitational force mg and friction. This resistive force. Due to this friction, this downward force increases. When this force increases, this downward acceleration also increases. This causes to object to comes to rest much shorter time. අඩු කාලයකදී ළමයි මෙයා rest එකට එනවා. Then you can observe that when the object comes to rest in much shorter time interval, this area reduces. That means maximum height attained by the particle decreases. Object again උපරිම උස අඩු වෙනවා ළමයි. So now you can observe that when the frictional force acting on the object, resultant force acting on the object increases, therefore acceleration increases. When this acceleration, this one is a deceleration, it acts opposite to the direction of the motion. No? When the deceleration increases, time taken to reach maximum height decreases, and also maximum height decreases. This area decreases. Right? These are the points you need to point out. Then you can consider the downward motion. When you consider the downward motion, at the starting point velocity is 0, then it moves to the downward direction due to the gravitational pull. Pute, again you should remember this frictional force always opposes the motion. Therefore, when it moves in the downward direction, this frictional force acts opposite to the direction of motion towards the upward direction. Now you can apply F equals ma for the motion of the object. Then mg at downward direction, friction at this frictional force acts opposite to the direction of motion. That means resultant force decreases. Therefore, downward acceleration decreases. For the first case, downward acceleration increases. In the second case, downward acceleration decreases. That means when the acceleration decreases, the slope of the curve should be reduced. Acceleration positively hari negatively hari lamai decrease වෙනවා නම් slope එක අඩු වෙන්න ඕන. For the upward motion, when the acceleration increases, you can observe that slope increase. When you consider the downward motion, two forces are acting in the opposite direction. Therefore, resultant force reduces. When the resultant force reduces, what happened to the acceleration? Acceleration reduces. That means slope should be reduced. When the slope reduces, you can observe that now this curve is not a straight line, right? But downward displacement should be equal to the upward displacement. Now you can observe that to obtain equal displacement, with less acceleration, it will take greater time interval. Make a T1 make a වැඩි වෙන්න. And when the base increases, altitude will reduce. Right? Make a U not a when the base increases, to make equal area, altitude will reduce. Half into base into altitude equal to displacement. When the time taken increases, velocity will reduce. Right? These are the points you need to know. Let me explain question from the beginning. First, we need to consider the motion of the particle if there is no frictional force acting on the object. Then you can observe that for the first phase, velocity decreases due to gravitational pull, gravitational deceleration, and the maximum height velocity becomes 0, then again falls down. These two displacements are equal. And constant gradient mean equal magnitude of two velocities should be equal. Project velocity magnitude there is no frictional force. But when the frictional forces are acting on the object, we can divide the motion into two sections. For the upward motion, you can observe that both gravitational force and frictional forces are acting downward direction. This downward force increases. When the downward force increases, downward acceleration also increases. Therefore, it will attain maximum height during much shorter time interval. Time interval. But you can observe that when the time interval reduces, area under the curve reduces. That means then you can consider the second part of the motion. In the second part, you can observe that particle moves downward direction due to gravitational pull. Frictional force always oppose the motion. Therefore, frictional force act opposite to the direction of motion. That means two forces are acting different opposite directions. That means resultant reduces. When the resultant reduces, acceleration should be reduced. That means it will take greater time interval respect to the first phase. To hit the ground. But these two areas should be equal. Why? When the base increases, for constant displacement, we should decrease. That means magnitude of the velocity of the particle when it hits the ground should be less than the magnitude of the initial velocity. Resistance friction against work kinetic energy loss. Therefore, velocity definitely reduced. No? Energy loss right lamai. Let's see the answers. The time it takes to reach the highest point from the starting point during the motion is equal to the time it takes to move from highest point to back to the starting point. There are different time intervals, right? B, it returns to the point of projection with the speed equal to the speed at which it is projected. C, a constant acceleration acts on the object throughout the entire motion. A, B, C. Incorrect statements which are the incorrect statement. 5. Right, Puthe? Right, Puthe. Let's see the answer for the question number 7. An aircraft moving with horizontal velocity of 100 meters per second. Velocity of the aircraft is given relative to the Earth is 100 meters per second. A missile can be projected horizontally from the aircraft at a velocity of 20 meters per second. This is a missile can be projected horizontally from the aircraft at a velocity of 20 meters per second relative to the aircraft. Velocity of missile is given relative to the aircraft. Relatively got it? If a missile is fired at a target in front of the aircraft while it is moving 500 meters above the ground level, at what horizontal distance from the target should be missile be fired? Today, first of all, you need to find velocity of the missile respect to Earth. Here, the velocity of the missile is given relative to the aircraft. No, you need to identify velocity of missile respect to Earth. V plus V M E A. Velocity of missile respect to aircraft 20 meters per second. Velocity of aircraft respect to Earth 100. Then the answer is 120 meters per second. That means velocity of the missile relative to Earth is 120 meters per second. Now you know the velocity of the missile relative to Earth. This is a horizontal projectile having initial velocity 120 meters per second relative to Earth. Today, first you need to identify time taken by the missile to hit the ground. Vertical displacement is 500 meter. Initial vertical velocity is 0, no? Half into 10 into t squared. Then 100 equal t squared. T is equal to 10 seconds. Then you can identify this range. Then you can find the horizontal displacement of the missile respect to Earth. To find the horizontal displacement of the missile respect to Earth, here you need to substitute velocity of the missile respect to Earth. Not relative to aircraft, right? We have find the value 120, time taken 10 seconds. 1200 meters. Answer is the third one. Haribude, we will discuss the other question in the theory class.